In this MP4 segment, I'm going to show you two different ways to do a difference in means test for populations, what we call a z-test. So we're going to use a z-statistic, which we've studied in the lecture. I've put a new version of the emergency room data under week 3 materials. We've got our 5 CPT codes, 99281 through 99285. I put a scroll bar there so we can scroll down. And for our first test, we're going to compare 99284 bills to the billed charges for 99283. Our null hypothesis is that the means of the billed charges for these two groups are the same. The alternative hypothesis is that the means for the two groups are different. That gives us a two-tailed t-test. And as shown in the MP4 for looking up critical z scores from the tables, either in the PDF or Monroe, at alpha of 0.05, the critical z score for a two-tailed test is 1.96. So we're going to compute our observed z and compare it to the critical z of 1.96. If the observed z is less than 1.96, we'll accept the null hypothesis. If it's greater than 1.96, we'll reject the null hypothesis and accept the alternative. So the first step in the analysis is finding the mean of 99284 and 99283. To do that, we'll use our average function equals average. Open our parentheses, and the data is in cells D2 colon through D11578. Close the parentheses, enter. So the mean is $304.58. I can do the same thing. I can just copy that formula in the same row under 99283, and I'll get the mean for 99283 of $208.20. Okay, next step, I'm going to find the standard deviation. The formula for it is STDEV dot P, open paren, G2 colon G11578. So standard deviation. And I can copy that, Control C, paste it in this row too, and that's the standard deviation for 99283. Here I want the variance. That's the square of the standard deviation, so I'm plus standard deviation caret 2, return. And I can just copy that, Control C, Control V, and you can see it is the square of the standard deviation here as well. We need to know the number of observations. Call it counts, equal count, open paren, E2 colon E 11 5 5 7 8. So there are 10,521 observations for 99283, and I'll copy that over here. And there are 11,577 observations for 99284. We're almost home. Last major calculation, we are going to find the standard error. And the standard error is the variance divided by the counts. So it's 0.47 for 99283, and it's 0.98 for 99284. The difference in means plus 30458 minus 20820 is $96.38, and the Z observed is the difference in the means divided by the square root of the sum of the standard errors. Or 79.87. The Z observed is 79.87. Z critical is 1.96. We reject the null. Accept the alternative. These two means are significantly different. So these show you the calculations. We can do this by using the data analysis tool pack. So we go to data, data analysis, scroll down, z-test for two sample for means, and 99284 is in G2, G11578. We find the observations for 99283 in E2 colon E10522. We hypothesize that the mean difference is 0. And here are the variances for 99284 and for 99285. We allow it to run, format our cells, and so here you see 99284 and 283 compared. Now let's spell it out. Here's the critical value two tails. Here's the Z that we computed. You want to double check. 79.87, 79.81, slightly different based on rounding. But you can see it's the same Z-test that we did using data analysis. It would be easy at this point to conduct this test for 99283 versus 99282. Let's just copy all of these, put them here. So what you can see is that the mean for 99282 is 132.42. Here's the standard deviation, the variance, the number of counts, and the standard error. And if I copy these values, you'll see that the difference between 208.20 and 132.42 is 75.78. The observed z, based on the difference in the means divided by the square root of the sum of the standard errors, is 42.43. And once again, it's in excess of the critical z, so we reject the null hypothesis. We could use the data analysis toolpack for this as well. Data analysis. Z-test 2-sample for means. Let's keep in mind our variance 4432.82 and 1632 for counts. So we'll do OK. And the variable range here for 99282 is C2 colon C 1633, and the variance for that is 4432.82. So here's the data range for 99283. 282. Data range for 99283. Hypothesized zero difference. Here are both our variances. We do OK. And since we had them inverted, the z here becomes 42.426. And here we calculated our z as 42.43. So spot on. 99283 versus 99282. We could make that a positive z if we inverted where we put the data ranges for the test. So what we've seen is calculating an observed z value based on a formula, and we found that the means for 99284 were significantly different from the mean for 99283, and subsequently the mean for 99283 is significantly different from the mean for 99282. I would leave it to you to check the difference between 99285 and 99284, as well as the difference between 99282 and 99281. I hope this has helped, and we'll see you in class.